So for the next part of our tutorial, what we're going to do is use object file I/O. To do object file I/O, we use an object output stream and an object input stream. The object output stream lets us write out an entire object at a time rather than just one piece of data, one string or one double, one int. You can still write things out like that as well with an object output stream, but that's not the real point of object output stream. The object output stream is designed for writing an entire object in one fell swoop. So you can make a complex object that had 200 data members in it, and then just with a single call it'll all go out to the file. So let's make a new project. Bye-bye. I'm going to do File Tutorial 2 will be the name of this one. And in order for our object tutorial to work, we need some kind of class that has some data that we're interested in. I could put it in the same file as this, but that is such bad programming that I'm going to actually grit my teeth and come over here and do new Java class. So I'm clicking on my package name, new Java class. I'm going to create a new class. I'm just going to call it MyData. And so what is MyData going to have in it? We're going to put a string called color. We're going to do a double called D. Those are our two pieces of data that we care about. And just to be a good little programmer, I think I will add getters and setters for these. So I'm going to highlight those two things and do refactor encapsulate fields. It'll add all my getters and setters for me. And that's enough. I mean, we could add a constructor and a toString and all of our fun stuff, but that's really enough. Okay, so we have a silly data class. We're going to go back to our main method, create an object. There's one more thing we need to do, though, and we haven't talked about inheritance yet, but to use the object output stream, we have to add two words to our object definition here, which is implements serializable. Now that's going to give us an error, but just like the other ones, we need to go and add the import for it. And so if we come up and look, we see Java import java.io.serializable. Without that, then we won't be able to use the object with the object output stream or the object input stream. So what this does is when we add this word, it brings in some methods from a class that Java gives us called serializable that handles writing to streams or reading from streams. And so it does a whole bunch of magic that we don't even care about. It just magically makes it work. So if you wanted to, you could do a show Java doc on serializable, and it would tell you a lot of information about it. But really all we need to know is that by doing that, implement serializable, it makes it so that the class that we just wrote has a write object method and a read object method that will get called behind the scenes. So we're going to go back over here. Let's create MyData. I'm just going to call it MD1 is equal to new MyData. And then MD1 dot set color We used red last time, so I'm going to use green. In MD1 dot set our number. What's our number going to be? How about 8.76? Now we want to write that object out to a file. So to do that, we're going to need to use the file output stream. So to write to a file output stream, we first need to create a data output stream and then create a file output stream from the data output stream. Sneaking a peek at my code over here. Okay. So I'm going to create the data output stream. Then I'm going to create the file output stream. Data output stream, and I'm just going to call it DOS, data output stream, is equal to new data output stream. And it wants us to add an import for it. I have this in the opposite order though. What I should have done is created the file output stream first and then created the data output stream as a result from that. So my notes up here are a little bit wrong. Create an file output stream. That's the first thing we do, and then we create a data output stream. So file output stream, FOS, is equal to new file output stream. I need to add the import for it. That still didn't fix it. No suitable constructor. The problem with this is I'm not passing in a file name when I try to create my file. When I do file output stream is equal to new, they have a really concise version of doing it, and I don't really like doing it the way that they're about to show it here. Maybe I'll do it the way that they're going to. I have totally botched this. We're going to rewind. So, fresh start. I'm going to edit that out of the video. So what we need is a file output stream and then an object output stream. Once we have those two things, then we can write our object out. So file output stream FOS, object output stream OOS, excuse me. It's complaining that it doesn't know what an object output stream is, so I click on that and do add import, for which I have already done for file output stream. So if I come up here, I'll see that my imports look like this. I have 3 imports at this point. Data output stream, that was a failed effort. I'm deleting that one. But we do have to have the import for file output stream and object output stream. All right, let's make our output stream. FOS is equal to new file output stream. We have to give it a file name. I forgot to make a file name variable. So I'm going to do that. I'm going to pretend like I already have that available to me. And when I create it, I can tell it that I either want it to overwrite the file or append to it. When I create my file, if I use a second parameter and I set it to false, it will overwrite the file. I'm going to add that as a comment. The false means overwrite the file if it already exists. True would append to the file if it already existed. Now I don't have a file name variable, so I'm going to come up here and add a string file name is equal to, and we're going to call this ObjectOutputStream.txt. Something like that. I don't know. Maybe just ObjectStream, or just Object.txt. There we go. All right, now that I've got this FOS is equal to new file output stream, it's complaining because it has an unreported exception. We're going to have to catch that. Nope, I don't want to do add a throw clause. That's cheating. Surround the statement with try catch. There we go. Same thing, I want an error message that makes some sense. So system.out.println could not open or could not create file. And then print out our file name. Now that we have the output stream open, we want to open the object output stream based on that. So OOS is equal to new object output stream, passing in our file output string into the constructor. And that's complaining. I've made a mistake apparently. Oh, it's probably just another, another unreported exception. I'm going to just go with this one for now. I'm not going to fix that error. This is going to assume that we've opened it correctly. OOS dot write object, and I want to write out my cute little my data object that I created way up here. So I'm going to write out MD1 there. And then I'm going to close it. OOS.close. I could close my file output stream as well. It's not strictly necessary to close the output stream, the OOS, if you're going to close the file output stream. Alright, now we've got all sorts of exceptions we need to handle. But we're going to let NetBeans do the heavy lifting. I'm just going to click on each one of these in turn, let it add the catch for it. Click on that one, add a catch clause. Now I come down here and it's showing a new error. Oddly enough, that fixed them all. So hey, good enough. Let's make this a slightly more intelligible error. System.out.println IO error writing file plus the file name. Okay. I'm going to go ahead and take this comment out It's a little bit too much for when we're trying to conserve space. Maybe I'll just put false means append. No, false equals overwrite. Yeah, that'll work. So that's our code, and I bet it's going to work. I'm going to want to put this inside of a method, which I haven't done yet. Right now it's all sitting in the main method. But we'll get there. I'm going to test this now, make sure it works. Clean and build. Run. Now it didn't do anything, but I didn't tell it to print a successful message. So it actually did do something. If I go out and I look for that file name. So underneath that file, that FOS close, I'm going to do system.println successfully created file followed by the file name. Now when I run it, at least I'll get a message. Successfully created file object.txt. Now this one is not going to be readable via Notepad. I can open it with Notepad, but whoa, that's pretty cool. So that is binary data. That is Notepad is treating as though it's Japanese or Chinese or whatever character set those are. We can't really take a look at them. We could go using a hex edit program to go see what was inside that data, but we're just going to assume that this has actually got our object in it.
One thing about doing it is that they'll censor.
Yeah. So let's take this code and put it in a method that'll return a true or false based on whether it successfully wrote it or not. So I'm going to cut everything from the place where we declared our file name down to the bottom of our catches. Cut all of that. Come up and make a new method. Public static boolean. I'm just going to call it, I don't know, write object file. And we need to accept the file name, and we need to accept our object. My data. Then I can paste all that stuff into it. If we get an error, we're going to return a false. If we catch that other error, we're going to return a false. If it all works, we're going to return a true at the very bottom. And the MyData object was actually called MD1. Now back up in main, I actually need to call it now. So boolean write OK is equal to write object file, and I wish I'd made that a lowercase w rather than upper, so I'm changing that. Passing in the file name, passing in the object. Why not print something else out, just indicating that it worked? All right, so that did not break the code. That's good to know. So we have write object file. Here's our write object file method. Just has all the code that we had in there. The only thing that I've changed was I did a return false for that catch, I did a return false for that catch, and I did a return true if it gets to the bottom without errors. So there's our write function, and I'll enclose this in a document. Now we're going to do a read object file method. let's go up here. Same idea. Public static boolean read object file. We're going to pass in the file name. Now I'm not going to pass in an object. This thing really ought to create an object and return it. And I'm going to leave a little bit of that to the viewer as an exercise to do themselves. So ultimately this should not return a boolean, it should return a myData object. We may as well stick a return true down here at the bottom just to stop the compilation error. And it's going to be the same kind of thing, but instead of a file output stream and an object output stream, we're going to create a file input stream and an object input stream. So we need a file input stream and object input stream. And again, this is shown on this page of our PowerPoint, among other places. They like to use anonymous objects where they do this new file output stream inside of another new. I don't like to do that. I always break them out into two things. So that's what we will do here. File input stream, FIN, object input stream, OIN. It's going to complain about both of those. I need to add the imports for them. So click on one, do add import. Click on the other, do add import. Now we can do FIN is equal to new file input stream, and we're going to pass in that file name. We're getting an error, of course. That error is that there's an exception that has been caught. So I'm going to click on that and do surround statement with try catch. Eventually I'll come back in and make this a better error message. Heck, why not now? System.out.println error could not open file plus file name. Alright, we have our file open. Now we need to create an object input stream from it. So OIN, object input, I meant to call that OIS and FIS for file input stream and object input stream. Forgive me for making these changes. FIS, file input stream, OIS, object input stream. I'm going to have to come down here and fix that to FIS is equal to new file input stream, and OIS is going to equal a new object input stream made from the file input stream. So why don't we have to pass that true or that false, that append thing, when we're creating the file input stream? We sure had to when we were down here making our output stream. Well, that's because you don't have the concept of appending or creating a new file if you're opening a file for reading. If you're trying to open it for reading, it just flat out better exist to begin with. So we don't need a secondary parameter there, a true-false parameter, to indicate the behavior if it doesn't exist. If it doesn't exist, it's just going to give us an error. Alright, now that I added that object input stream, it's giving me an error, unreported exception. I'm not going to add that exception yet. I'm just going to leave it for now. So, we have an object that we want to read, and it's a myData. So I'm going to call it myData MD or new MD or something. Yeah, just MD. And I'm going to do MD is equal to OIS dot read object. Now let's close the input stream. Close the file stream. Let's print a message saying that we read from the file. And now would be a good time to go ahead and add our extra catches. Here's an unreported exception. Have to handle that one, so I'm going to add a catch clause for that one. That one makes most of them go away. Here's a problem. It says incompatible types. Object cannot be converted to my data. The problem is that read object returns a generic object that we have to then cast to our format. Now there's another catch we have to handle. This one is class not found. That's if the object that had been written out was of one type class, it was a string or something else, and now we're trying to read it in and we're trying to cast it to the form of my data. Well, the classes may not match, and if they don't match, it's going to throw an exception, so that's a final catch that we have to add. So now we have filled up our code down here with some more exceptions we have to handle. Not too many. An IO exception and a class not found exception. So let's make some better error messages. If we catch an IO exception, then we will print out IO exception, or IO error colon IO error on file, like that. And this one's pretty cryptic. The user's not going to have any idea what a class means. So that error message, I may just make it a little more vague, like IO error isn't. And data file is in unexpected format. There we go. They won't have a clue how to fix that, but that's okay. They should never see that error. The way we would get that error is if we tried to write out one type of object, one type of class, and we tried to read in another type of class. And we're not going to demonstrate that error.
Okay.
So adding some comments for clarity, always a good idea. Let's just say open our file for reading as an object input stream. Create a object reference. Read the object from the file. And close our file. So, just to prove that we actually read our data, let's print it out now. So underneath this thing that says read object from file, I think what I'll do is let's just do system.out.println and we're going to print md mydata dot get color plus a space plus md dot get d, that number. Hopefully we'll see the same thing that we saw. Well, it would have, except we never actually implemented a call to this function. We're going to have to go down to main and add a call to this function. So, where's main? Here we go. Boolean read OK is equal to read object file, file name, and then system.out.println read OK is equal to, just to establish that it returned a true or false successfully. I may have forgotten to add return falses to my catch statements. I need to make a mental note to go do that. So the problem with the idea of this code is that we have read object, we're creating an object, we're reading it in, but we're never passing it back to the calling program. And you might think that we might just be able to add another parameter here, like that. Don't do that though, because Java is not a pass by reference language. It's a pass by value. So we can't create a new object and then have that value come back to it. We're going to have to return it. So rather than make it a Boolean, why don't we make it a MyData? Then down here, after we've read our object and everything looks great, we're going to return our object. But if that failed, then we're going to return a null instead. And that's how the calling program will know that it didn't actually work. Now we're going to have to fix our call to read object as well. So I'm going to come back up here, and where it says Boolean read OK, that's not really good. Instead, we need to declare MyData reference. I'm going to call it MD2 because this one was called MD1. And there we go. And I don't think I'm going to print anything. Yeah, sure, why not? Let's go ahead and print MyData2, even though it's not going to look intelligent. But at least we'll see something. If it said null, we would know that it didn't work. We could put an if statement there. If MD2 not equal to null, then it read it okay. Else, print an error message. Do we really need all that? I don't know. But at least we're getting the object back now. So what the change that I made is instead of being a Boolean, we made it of type MyData. After we created our object, read it in, and closed our files, we returned that object reference. But if it failed, we returned null instead. And so then when we needed to call read object, we stored its return value in a MyData reference, and then we could check to see if it was null or not. Because if it was null, then it means that an error occurred. What's this little comment here? No comment. All right. So I'll post these sources, but I hope you worked through them rather than just copying and pasting the sources. I know these were a little bit long. Each tutorial was a little more than 30 minutes each. But it's really good practice for the next assignment. The next assignment will actually be pretty easy based on this stuff.